Good morning, guys. In this video, we'll talk about frames and machines, and we'll explore the difference between truss frames and machines. So as we said, guys, in the previous video, the truss is a structural body where all the members are two force members. What does this mean? What is two force member? You can go to the previous videos and see the explanation of two force members, and I can give you a summary. Two force member means, guys, that I only have forces on the joints, which means if I have a truss like this figure, all the forces exerted are exerted on the joints. So there is no member where the force is not exerted at the joint, it is exerted on the member itself. If I have one member where the force is not exerted at the joint, it is exerted at a point on this member, then this member, guys, will no longer be a two-force member, which means, guys, this is the case of the frame. So the frame, guys, as you can see in this figure, at least one member is not a two-force member. So at least one member has an external load applied on the member and not on the joints. This is called frame, and we will discover now, guys, how to solve such frames. Now, what's the difference between truss frame and machines? It is, in fact, guys, that truss and frames are stationary, while machine has at least one moving part. So I have a pulley, I have a cable, I have at least one moving part in the machine. So this is, guys, the main difference between truss frame and machines. And remember, the main difference between truss and frame is that the frame has at least one multi-force member. Multi-force means it is not a two-force member. I want you guys to remember that in the truss, each member has two forces at the joints that are opposite, like this case it is in tension, and that has the same direction of the member. And this direction is called axial. So it is in the same direction of the member, so they are axial. Now this is the case of two force member. Because in fact, guys, if you go to the video of two force member, you will see that the equilibrium could only happen if and only if these two forces are opposite of the same line of direction, like this case. So basically they are axial, so they have the direction of the member, and this is the case of trusses. Now in the frame, guys, in fact, in the frames, I don't have, or at least one member doesn't have the properties of two-force member. It is a multi-force member, which means, guys, the forces are not axial. So for the truss, the forces are not axial. In fact, the forces resemble to the reactions of the pin. Which means, guys, at each pin in the frame, I have two reactions or two forces on this member. These two forces are axial or could be assumed axial if this member has not any external force on it. So guys, in order to more understand how to solve for frames and what is a frame, I want you to start by this example right here. As you can see, guys, in this example, I can be sure that this is not a truss. First, member BC is subjected to this external force P that is not applied neither on B nor on C, which means this member could not be a two-force member. And member AB has an external moment M, which means also that this member cannot be a two-force member. So this is basically a frame. If I take a deep look on this frame, I can see that I have how many unknowns? I have 4 unknowns because in fact I have 2 pins here. So at C, I have also a pin. It is not a roller, which means I have 4 unknowns. And I know, guys, that in 2D, I only have 3 equations, sum of fx, sum of fy, and sum of moment. So how can I solve such problem if I only have 3 equations with 4 unknowns? Basically, guys, I have 4 unknowns if I take this whole frame as my free body diagram. So if I take this whole frame as my free body diagram, I will have 4 unknowns with 3 equations. And this could not be solved. So what should I do? I should search for the pin that is joining the members of this frame. So where is the pin joining the members of this frame? It is basically at B. So guys, at B, I have a pin, and I know that at a pin, I should have some reactions. Now, why here, guys, I'm not showing these reactions? Because in fact, these reactions are internal if I take the whole frame as my free body diagram. So what should I do? In fact, guys, if I need to solve a frame having 4 unknowns, I should separate the members of this frame at the pin. So I should separate the members, which means I should separate AB from BC. Alright, if I separate AB from BC, I should show the reactions of the pin joining these 2 members. And here, guys, you should not be confused with the case of truss, because in fact, if I disassemble the member of the truss, I will only see the axial force, because the truss has 2 force members. Now here, since I have a frame, and since in this frame, these 2 members are multi-force members, this means, guys, that the force here at B is not axial, unlike the case of the truss. Instead, guys, at B, I have 2 forces, Bx and By. And guys, the resultant of Bx and By in this case could never be axial or of the same direction of the member. Because, guys, if this force was axial, then this means that this is a 2 force member, which is not our case. So, guys, basically what I should do, I should separate member AB and member BC, put the internal forces at B. So what are these internal forces? Bx, By, and don't forget to flip them on the second side like we did in the cut for the trusses. So I should flip them here. So if I take Bx to the left, Bx in the second part will be to the right, so that if I connect these two members again, Bx will vanish. This internal force will vanish. And the same goes for By. So if I take it downward, I should take it upward in the second part. And of course, I can assume any direction. Now, guys, what are the consequences of separating these members? Can I solve now my system? If I take the first member AB, I still have four unknowns, AX, AY, BX, BY. If I take member BC, I still have four unknowns, BX, BY, CX, CY. So guys, what should I do? In fact, I should take both members separated from each other. So I should take AB and I should take BC. How many equations do I have for AB? Three equations, sum of x, sum of y, sum of m. How many equations do I have for BC? Three equations, sum of x, sum of y, sum of m. So how many equations do I have if I solve for both separated members? 6 equations. Now how many unknowns do I have for both separated members? 1, 2, 3, 4, 5, 6. So I will not count Bx and By again because in fact, guys, they are the same as here, except they are opposite. So basically, guys, I have 6 unknowns and 6 equations if I solve for these two members separated. And this means, guys, that if I separate these members in such frame, I can find all my unknowns. So even, guys, if the question is not to find the forces at B, the internal forces at B, no, if the question basically is to find the reactions at A and C, and I know that there are 4 reactions, I should separate the frame, solve for both separated members, then guys, I can find the reactions at A